Here, we have used the IoT platform in order to create a conveyor belt and add functionalities to it by using NODERED. First of all, we launched the dashboard of the IoT, which is like this, and then we add a device by using this option. Right now, I have already added a conveyor belt, and the status of this is disconnected because I have not connected to it yet. In order to connect to this conveyor belt, I need to have the device ID, which is conveyor_belt, and need the access token, which is needed when creating the device. Now, to connect the conveyor belt, I enter the device ID and the password. And once I click, it will be connected. And when I change the speed, the device data and its status can be seen from the IBM dashboard. Yeah, these are the sensor data that we have received after changing the speed. Now, in the NODERED application, we have connected this to the conveyor belt by using this IoT in node, where we have added the API key of the conveyor belt. Here, we need to store all the device information such as device type, ID, and events, and the data comes in the JSON format. Here we need to add the API key and token of the application. And once this is verified, our IBM platform is connected to the simulated device. Now we have three major functionalities in this application. The first is to calculate the operation speed of the conveyor belt. In this function node, here what we have done is we have compared the status of the conveyor belt, which is in the running. If the running is true and the start time is 0, then we calculate this timestamp, which is stored in the start time. And in case the device stops running, then the value of the d.running goes false. And then we calculate the time difference between the two timestamp and we calculate the operation time. Once the speed is calculated, since we have already started the conveyor belt, so we have already received a message that the conveyor belt has started. The second functionalities that we have used is, in case the conveyor belt speed has crossed, in case the speed of the conveyor belt is above 2 RPM, it will display a message that the conveyor speed has crossed the limit of 2.0 in our Twitter. We have linked the Twitter account in this node. Here we have added the API key and the access token, the API secret key, access token, and the access secret key from the Twitter. Now let's increase the speed of the conveyor belt above 2.0 to see if the Twitter has been posted. Let's refresh the Twitter. Yeah, the limit has crossed the danger limit. Now let's see the final functionality of this application, where an email is sent whenever the speed limit has crossed or there is any change in speed of the conveyor belt. Since we have already changed the speed of the conveyor belt multiple times, so we have already received an email. In this function method, what we have done is, first we have the current speed of the conveyor belt, which is stored in the current speed, and the previous speed is stored in this previous speed variable. We compare the value of the previous speed and the current speed. In case there is a difference, then the message is sent. And in case the current speed is 0, then it is a notification that the conveyor belt has stopped and that the message is sent in the Gmail account that we have set in the email node. Here in the email node, we have used the Gmail server, Gmail mail server, and we have used the user ID as the account that we are going to use to send the emails and the password of it. In order to use this application, we have to disable the authentication methods in our Gmail account. Now let's check our Gmail account to see if we have received the messages or not. Since we have changed the speed multiple times, so these are the messages that we have received each time we changed the speed. Finally, now when we stop the conveyor belt, even when we reduce the speed of the conveyor belt, we will receive an email message. These are the messages that we have received. And finally, now we are going to check if it sends a message when we stop the conveyor belt. Since the conveyor belt has stopped, there is an email notification that the conveyor belt has stopped. And also it has shown the time until which the conveyor belt has run, which is 11 minutes and 23 seconds. So with the help of IBM IoT platform, we have successfully added functionalities to the conveyor belt. And other than that, it also shows the graph. It also shows the graph of how the speed has been changed. And finally, since we had stopped, so the final speed of the conveyor belt is 0. Thank you.